NASA's Parker space probe has become the first spacecraft to touch the Sun. It flew into and through the Sun's upper atmosphere called corona. Corona is the outermost region of the solar atmosphere, and it's a mysterious region. Corona becomes visible from the Earth during a total solar eclipse. Its temperature is about 1,000,000 degrees Celsius. That's way hotter than the surface of the Sun, which is more than 5,700 degrees Celsius. Scientists haven't been able to explain the anomalous heating of the corona. To solve the mysteries of the corona, we had to send a probe to the Sun. NASA launched the Parker Solar Probe in 2018 to study the solar corona. And after 3 years of journey, it finally hit its target. In its planned journey of 7 years, it is expected to make 26 close approaches to the Sun. April 2021, approach was the 8th and first to enter the corona. Parker remained inside the solar atmosphere for nearly 5 hours during this venture. As Parker entered the corona, its camera took these images of plasma streams around it. But the important question is that, how did it survive there without melting? Several things keep the Parker space probe working under such conditions. The first, its white heat shield that reflects off the front and keeps things cool at the back. The shield is made of 2 materials: carbon-carbon and carbon foam. Secondly, solar limb sensor keep the heat shield in the right configuration. Then, the solar probe circulates water to prevent the solar cells from overheating. And finally, the corona has a high temperature, but it isn't dense. The Sun is made of plasma particles, and their energy and temperature are proportional. While the corona's temperature is over 1,000,000 degrees Celsius, the density of those particles in the corona is significantly less. Hence, there are very few particles that touch the probe. Parker made several crucial discoveries in the Sun's upper atmosphere. It detected fluctuations in the solar magnetic field as it entered the corona. The solar wind gushes out outside the corona, pushing the solar material away. But inside, the magnetic field is much stronger, and the solar material moves slower. The boundary between the two is known as the Olfin critical structure. Parker found that instead of a smooth transition, the structure is wrinkled. And this happens because of the huge flow of particles that escape the corona. Parker also investigated a phenomenon known as solar switchbacks. These are the Z-shaped kinks in the solar wind's magnetic field. We've known about switchbacks since the 1990s, but now Parker has detected them inside the solar atmosphere. Probably, some of the switchbacks come from the lower corona. Still, it's not yet known that where or how they form. Parker dipped as low as 18.4 solar radii during its corona drive. It is now aiming to go as close as 9.86 solar radii from Sun center. So we can expect to get some pretty fascinating answers in the future.